Hello everyone, welcome to Honest YouTube channel. Today I am going to solve the class 12th mathematics board exam paper which was conducted on 9th of February, and we are going to solve the section A of the question paper. The question paper that I have taken is bearing the question paper code of 65 oblique 4 oblique 2, which you can see here, and it is a set number 2. So let me give you a brief introduction of the question paper. There are total 38 questions in this question paper, and you have to attempt all the questions. That means all the 38 questions are compulsory. However, the internal choices are provided in some of the questions. The total 38 questions are divided into 5 sections, starting with section A, which contains 18 MCQ question and 2 assertion region based question. So therefore it makes total of 20 marks. And the section B contains 5 questions, each of 2 marks, so which makes it total of 10 marks from section B. The section C contains 6 questions from 26 to 31, and these are short answer type, and each of the questions are of 3 marks, so which makes the section C totaling of 18 marks. Coming to section D, it contains 4 questions and they are long answer type, each of 5 marks, so making the section D of 20 marks. And the last section is case study based questions. So there are 3 case study here, and each case study contains uh, 3 to 4 questions, and overall they carry 4 marks. So section E makes total of 12 marks. So if we add 20 plus 10 plus 18 plus 20 plus 12, we get maximum marks for this question paper as 80. And the time allowed for to solve this question paper is 3 hours. So in this video I am going to solve the section A, and in the later videos or in the other parts of the video I will solve the subsequent sections B, C, D and E. The section A is also very important from the perspective of competitive exams like JEE mains and COT and other state engineering examinations. So let's start with the section A. So section A, as you can see, the first question is from three-dimensional geometry. Okay, it is given that the lines 1 minus x upon 2 is equal to y minus 1 upon 3 is equal to z upon 1, and 2x minus 3 upon 2p is equal to y upon minus 1 is equal to z minus 4 upon 7 are perpendicular to each other for what value of p. Okay, so you have to find the value of p such that these two lines are perpendicular to each other. So first of all, we have to know that this question is asked from the chapter of three-dimensional geometry. So in three-dimensional geometry we have studied that in Cartesian form the equations of lines are given as x minus x1 upon a1 is equal to y minus y1 upon b1 is equal to z minus z1 upon c1. This is the first line. The second line is x minus x2 upon a2, y minus y2 upon b2 and z minus z2 upon c2. So if these two lines make an angle of theta, let us say this is L1 and this is L2, and there is an angle of theta between them. So there is a formula to calculate the theta, uh, and that formula is given here. Cos theta is equal to modulus of a1 a2 plus b1 b2 plus c1 c2 upon under root a1 square plus b1 square plus c1 square multiplied by square root of a2 square plus b2 square plus c2 square. So where a1 a2 b1 b2 c1 c2 are the direction ratios of the line L1 and L2 respectively. So first of all we have to notice that the given equations of the line are not in the standard form. So first of all we have to convert the question in the standard form, and then we will compare it with the formula, and by putting the values of a1 a2 b1 b2 c1 c2 we can find the value of b. So in this particular case it is given already that L1 is perpendicular to L2. So if L1 is perpendicular to L2, that means theta will be 90 degree, and we know cos 90 is equal to 0 degree. So if cos 90 is 0, then the denominator of the RHS will become 0 and only numerator will remains, and that numerator should be equal to 0. So if we change the equation of the line L1 in standard form, we will get the value of A1 as -2, B1 as 3, and C1 as 1, which you can see here I have done already. And by changing the equation of line L2 in standard form, we can also find the value of A2, B2, and C2. Okay, so we find out that A2 is equal to P, B2 is equal to -1, C2 is equal to 7. Now multiply these two values and you will get the values as -2P, -3, plus 7 equal to 0. So that gives -2P is equal to -4, and that gives P is equal to 2. So correct answer will be option number C, which you can see here given as 2. So for the value of P is equal to 2, these two lines will be perpendicular to each other. Okay, now let's come back to question number 2. So the question number 2 is asked from the chapter of linear programming, or we can say LPP. So here already a graph is given whose feasible region is given, and the corner points are given as A, B, C, and the origin. What you have to do is to find the maximum value of this z is equal to 4x plus y. In order the given option, one option should be correct. So how do we do that? So first of all, we uh, calculate the vertex points, and for that particular vertex point we calculate the corresponding value of z. So here you can see in the table I have prepared already, there are four corner points: origin A, B, C. So for origin it is coming 0, for A it is coming 50, and for B it is coming 110, for C it is coming 120. So the maximum value is 120, and that correspond to point C. So the answer will be 120, that is option number C. Okay, so for question number 1 also option number C was correct, and for question number 2 also option number C was correct. Now let's come back to question number 3. Question number 3 contains a question from the chapter of probability. Probability is the last chapter, but certainly very important chapter. And here it is, the question asked from the topic of random variable. So probability distribution of random variable is given as x value as 0, 1, 2, 3, 4, and p of x as 0.1, k, 2k, k, and 0.1. What we have to find here? We have to find the value of px corresponding to x equal to 2. So first of all, we have to calculate the value of k here, and then we can see from the table for x, when x is getting 2, the probability is corresponding to 2k. So what's the concept involved here? So in the case of random variable, the sum of all the probabilities in a probability distribution should equal to be 1. That is summation pi, where I varies from 1 to n, it should be equal to 1. Okay, that means 0.1 plus k plus 2k plus k plus zero point 0.1 should be equal to 1. So which gives 4k is equal to 1 minus 0.2, which gives 4k equal to 0.8, and that gives 4k is equal to 0.2 or 1 by 5. This is not the answer. Then we have to find the value of p of x equal to 2. So from the table we can see p of x equal to 2 is getting a probability of 2k. So if k value is 1 by 5, then 2k value will be 2 by 5. Okay, so if we check the option, 2 by 5 is coming with the option B. So option B is the correct answer. Now let's go to the question number 4. Question number 4 is from the chapter of determinant. So here it is a matrix of order 3 by 3, and it is saying that what is the value of A21 C11 plus A22 C12 plus A23 into C13. So here A is the general element of the second row and C correspond to the cofactor matrix of the first row. So if you have studied determinant chapter, you should know that if we multiply the elements of any row or column with its corresponding cofactor of the same row or column, we will get the value of determinant. But if we multiply the elements of any row or column with the corresponding with the cofactor of any other row or column, we will get the determinant value as 0. So here we can see easily it is asking us to find the product of elements of second row and multiplying them with the cofactor of first row. So second row and first row will give value as 0, because if second row element are multiplied with the second row cofactor, then the value would have been determinant value, but here it is not like that. Here it is opposite, so the value will be 0. The 0 is given in option number B. Okay, now let's go to the question number 5. You can see the question number 5, it is from the chapter of matrices. So here it is given a 2 cross 2 matrix. Is A, whose elements are 1, 3, 3, 4, and an equation is given in the form of A square minus K minus 5 pi equal to null matrix. It is not 0, it is null matrix. So what we are asked to find, we are asked to find the value of K for the given equation. So using the value of A, we have calculated the value of A square first. So how to calculate A square? We will write A into A, then first matrix multiplied by again the same matrix. So how we will multiply? You take the first row of this and the first column of this. So here you will get this first row and first column. You get the product matrix first row first column element. First row second element will give you first row second column element. Okay, so multiply in the same function, same manner, you will get A square as 10, 15, 15, 25. Now put the value of A square, A, and identity matrix in the given equation. You will get the value of K as, which I have already solved here. So identity matrix will be 1, 0, 0, 1, and by adding all this and solving it, you will get the value of K as 5. K equal to 5 correspond to the option number B. Okay. Now let's go to question number 6. Question number 6 is asked from the chapter of continuity and differentiability. Here question is given e to the power x square y is equal to c. We are asked to find the value of dy by dx. So whenever two variables are given in a power, so there is only one formula through which we can differentiate, that is logarithmic differentiation. So what we have to do here, first of all take the log on both sides. So when you take the log uh, on LHS, you will get log e to the power x square y and RHS log c. So here you can apply a property of log, that is log of a to the power m. So this power will come in the front and this will become m log a. Similarly here you can see x square y has come in the front and log e and equal to log c. So here we generally assume that log has the base of e. So whenever we take the log of e at the base e, we will get the value of is 1. So what we got, the final equation is x square y is equal to log c. Now we will differentiate this equation with respect to x and we will get 2xy plus x square dy by dx equal to 0, or dy by dx equal to minus 2xy upon x square, or dy by dx equal to minus 2y by x, and this correspond to the option number B. Okay, so for question number 6, option number B is correct. come to question number 7. Question number 7 is asked from the chapter of continuity and differentiability again, and this is from the topic of continuity. Here a function is given x square fx is equal to x square minus c square when x is less than 4 and cx plus 20 when x is greater than or equal to 4. We are asked to find the value of c if the given function is continuous for all real numbers. So if this function is continuous for all real numbers, then it should also be continuous for x equal to 4. So by using the definition of continuity, we can say the left hand limit, right hand limit, and the value of function at that particular point, all these three are equal, then the function will be continuous at that particular point. So here that particular point is 4. Now we will calculate the value of left hand limit at 4 from left. So we will get LHL as 4 square minus c square or 16 minus c square. Similarly, right hand limit, if we calculate, we will get 4c plus 20. Now equating these two value to the function of value of function at x equal to 4, we will get 16 minus c square is equal to 4c plus 20. Then if you solve this, you will get the equation as c square plus 4c plus 4 equal to 0, which is nothing but c plus 2 whole square equal to 0. So that gives c equal to minus 2 comma 2. So both the value of c are equal, so minus 2 is the value for which this function will be continuous. So option number A is correct for question number 7. Now let's go to question number 8. This question is asked from the chapter of integrals. So here the concept of integration, and that too definite integration, is used. So here we are asked to find the integration of modulus x from minus 1 to 1. So first of all, we have to learn what is modulus function, because modulus function is not continuous everywhere. So here mod x is given. So mod x is graph is something like this. By looking at the graph, we can say this function is not continuous at x equal to 0. So we have to break the integration in two parts using the point 0. So I have already done that. We have to do the integration in two parts, that is from minus 1 to 0 and 0 to 1. And we have to also note that from minus 1 to 0, the integration will be of minus x, and from 0 to 1 the integration will be of plus x, okay, as per the definition of mod x. So let us do that. If you do that, first integration will be from minus 1 to 0 for minus x square by 2. The second integration will come as x square by 2 from 0 to 1. If you solve this, you will get 1 by 2 1 by 2, and if you add this, you will get answer as 1, and this 1 answer is corresponding to option number C. So option number C is correct for question number 8. Now let's go to question number 9. Question number 9 is asked from the chapter of differential equation. So here what are we asked to find? That the given differential equation will contain how many arbitrary constant in its particular solution. So the differential equation given here, it is log dy by dx equal to 3x plus 4y. First of all, we have to remove this log, then only we can find the solution. So what to do to remove the log? Simply use the definition of logarithm. So logarithm say if we write log of y the base e equal to z, that means simply e to the power z is equal to y. So by applying this definition here, we can easily write e to the power 3x plus 4y equal to dy by dx. Now, in the concept of exponent, so when the base are same, the power should be added, or we can say when the base has to be splitted between two parts, we can separate as a and b. So simply e to the power 3x plus 4y can be written as e to the power 3x into e to the power 4y equal to dy by dx. Now separate the variables. So this is variable separation. E to the power 3x dx equal to e to the power minus 4y dy. Okay, rearrange the equation, and after rearranging, if you integrate both sides, you will get integration of e to the power minus 4y dy is equal to e to the power 3x dx integral plus c. Remember, we will write the constant of integration on x side. Okay, so integration of e to the power x and differentiation of e to the power x both are same thing. So this gives e to the power minus 4y upon minus 4. So here first of all you have to assume something minus 4y as t. So this will become e to the power t. Okay, and from here you will get dy by dt is equal to minus 1 minus 4 dy by dt is equal to minus 1, or we can write dy is equal to minus dt by 4. So what we have to integrate? We have to integrate basically e to the power dt, and in the place of dy you can write minus dt by 4. So this will give minus 1 by 4 outside and e to the power t dt. E to the power t dt integration will be e to the power t, and after solving this you can put the value of t as minus 4y. That's what I have written here. So either you can remember this also, that you have to just divide the uh, integral by the differentiation of minus 4y. Similarly, on the RHS side, it is e to the power 3x by 3 plus c. And there is a condition given in the question that when y gets the value of 0 for x equal to 0, then if we put the value of x equal to 0, we will get the value of y equal to 0. So by putting these two value, we can find the value of c, and by solving we are getting the value of c as minus 7 by 12. So this will give the required particular solution for the given differential equation, that e to the power minus 4y upon minus 4 it is equal to e to the power 3x on 3 minus 7 by 12. So we can simply see that there are no constant involved here, only variables x and y. So if no constant, that means number of constant equal to 0, and this number of constant equal to 0 correspond to option number C. So option number C will be the right answer for the question number 9. Now let's go to the question number 10. Question number 10 is asked from again the chapter of matrices. This is a very basic question, yet very logical. Here a matrix is given AC0, BD0, 0, 0, 5 as a scalar matrix, and we are asked to find the value of A plus 2B plus 3C plus 4D. So how do we find the value? So we should know what is the definition of scalar matrix. So scalar matrix is basically a type of diagonal matrix, and diagonal matrix is like this. If you take a 3 by 3, so except the diagonal elements, all the other elements should be 0. Okay, that's the diagonal element. And in the case of a scalar matrix, the diagonal matrix will become a particular case when all the diagonal elements equal to some constant k, and all this constant will be equal. So if we apply this concept on the given question, we will get A as 5 and D as 5 by looking at the matrix, and the value of B and C as 0. If we put the value of these two in the equation of A plus 2B plus 3C plus 4D, we will get the value of 25, because these two will get to reduced to 0, and A is 5 and 4D means 4 into 5, that is 20. 20 plus 5 is 25. So 25 is option number D. So option number D is the correct answer for the question number 10. Now let's go to the question number 11. The question number 11 is again asked from the chapter of matrices. So here 2 by 2 matrix is given, 2 1 minus 4 minus 2. What we are asked to find that the value of I minus a plus a square minus a cube plus, and so on. So first of all, here a is given as this, and then we will find the value of a square. So in the questions like this, we have to observe the pattern, and by observing the pattern, we can find the value of the given expression. So if we carefully calculate the a square, we have to take the first row of this A and the second, sorry, first column of this. So this will give the first row and first column element of the product matrix, which is 4 minus 4. And in the similar way, we can calculate the value of other entries. Okay, so here you can see the A square is coming as 0 0 0, which is null matrix, empty matrix, zero matrix, or void matrix, whatever you can call it. So if A square is coming as 0, then A cube, A to the power 4, A to the power 5, and A to the power 6, and so on will all come as null matrix, okay, or zero matrix. So that means in the given expression, after I, uh, the value of A square minus A cube and so on will be 0. So how to calculate the value here? So let me correct this. I minus A, so this will get reduced to I minus A, and I is identity matrix, so 1 0 0 1, and A is 2 1 minus 4 2, 2 1 minus 4 minus 2. So this will become equal to 1 minus 2, this 0 minus 1, and this 0 plus 4, and this 1 plus 2. And if you solve this, you will get as minus 1, 4, and 3. And if you compare it with the given option, you will get the option number A. Okay. So earlier I have done it wrong. Now I have corrected it. So option number A is the right answer for this question. Okay. Now let's go to the question number 12. This question is asked from the chapter of determinant. So here we are given with the A inverse as 1 by 7, matrix 2 1 minus 3 2. So as we know, inverse matrix is something which is obtained by the original matrix. So if we obtain the original matrix with its inverse, we will get the identity matrix. By using this formula, we can easily calculate A. Since it is a 2 by 2 matrix, we can assume the 4 elements of A as A, B, C, D. And if we multiply it by A inverse, which is given as 1 by 7, 2, 1 minus 3, 2, we will get 1 0 0 1. By multiplying in the similar fashion, as I will explained earlier, you can get LHS as 1 by 7 common, 2A minus 3B, A plus 2B, 2C minus 3D, and C plus 2D, which is equal to 1 0 0 1. Taking the 7 on the RHS and equating the corresponding element of the two matrices, we got the 4 equation. 2A minus 3B equal to 7, A plus 2B equal to 0, 2C minus 3D is equal to 0, C plus 2D equal to 7. Now for A and B, we have to take the equation number 1 and 2 and solve it simultaneously. You will get the value of B as minus 1, A as 2. And for C and D, solve the equation number 3 and 4 simultaneously. You will get the value of C as 3 and D as 2. Now put the value of A, B, C, D in matrix A. You will get the value of matrix A as 2 minus 1, 3, 2. So this 2 minus 1 3 2 is correspond to the option number B. Okay. So option number B is the right answer for this question number 12. Now come to question number 13. This question is asked from the chapter of differential equation. Here we are asked to find the integrating factor for the differential equation. So as you know, integrating factor is calculated when differential equation is in the form of linear differential equation, and by carefully looking at the given equation we can easily observe that it is fitting in the format of dx by dy plus p1y is equal to q1, sorry, p1x is equal to q1. So if we rearrange the given equation, you can see that I have done that here, dx by dy plus in bracket minus 1 upon y x plus is equal to 2y. If you compare this with the standard format, you will get p1 as minus 1 upon y, and the corresponding integrating factor will be e to the power integral p1 dy. Put the value of p1 as minus 1 upon y, so integration of 1 upon y is log y. Taking negative power ahead of log, we will get log y to the power minus 1. Now y to the power minus 1 is 1 upon y, and e and log will get cancelled. So integrating factor is 1 upon y, and this 1 upon y correspond to the option number D. Option number D is the correct answer for the question number 13. Now come to question number 14. Question number 14 is asked from the chapter of vector. So here equation of a line is given in the vector form, which is r vector is equal to a vector plus lambda b vector type. So as you know that in 3D this kind of line is represented like this. A vector correspond to any general point on the given line, and this lambda b vector corresponds to a vector to which this vector is already parallel. So if we find the direction ratios of this b vector and multiplied with the one of the options among the four options, and for which option it is coming dot product as 0, that will be the correct option. So using the dot product or scalar product, we know that the two lines equation are given as r vector is equal to a1 plus lambda b1 vector, and r vector is equal to a2 plus mu b2 vector. Cos theta can be given as modulus of b1 dot b2 divided by modulus of b1 into modulus of b2. So if theta is equal to 90 degree, cos 90 will be 0. That will reduce this expression to b1 vector dot b2 equal to 0. So if we look carefully at all the options, so by taking b2 as I vector I cap plus 3j cap plus 5k cap and multiplying it with b1, you will get b1 dot b2 equal to 0. As you can see, I have already done that here. So the correct option for this question will be option number B. Let's go to question number 15. Now this question again is from the chapter of vectors. So here three vectors are given, and these three vectors corresponds to three sides of a rectangle like this. Okay. So what are we asked to determine here? We are asked to determine that what will be the nature of this triangle, what kind of triangle these three vectors will represent if they are the sides of the given triangle. So in this type of question, we have to first find the modulus of all the sides or magnitude of all the sides. So as you know, if a vector is represented like a vector as a1 I cap plus a2 j cap plus a3 k cap, its modulus a vector mod or a simply is given as square root of a1 square plus a2 square plus a3 square. So applying this formula in all the three sides, you will get a mod or as root 6, b as root 35, and c as root 41. It is very clear from all the three values that their square will be the sum of other two sides. That root 41 square is equal to root 35 square plus root 6 square. That is c square is equal to b square plus a square. So it is a very clear case of right angle triangle. So these three sides will represent the right angle triangle. So option number D will be the right answer. Okay. Option D is the correct answer here. Now let's go to question number 16. As you can see, the question number 16 is again asked from the chapter of vector. So here it is asking that if A is any vector such that mod of A is equal to A, and we are asked to find the value of the given expression that A vector into I vector I cap modulus square plus A vector into J cap modulus square plus A vector into K cap modulus square. So for this kind of question, first of all, we have to assume A vector as something. So we have assumed A vector as, you can see, A1 I cap plus A2 J cap plus A3 K cap. So for this, modulus will be under root A square plus A2 square plus A3 square. Here you can also see, if we square it on both sides, you will get A square as A1 square plus A2 square plus A3 square. So let us calculate the value of first term in the given expression, that is A vector into I cap. So A vector into I cap is basically the vector or cross product of A vector and I cap. So A vector can be written as A1 I cap plus A2 J cap plus A3 K cap, and I cap can be written as 1 I cap plus 0 J cap plus 0 K cap. Okay. Now we can easily calculate this vector product by using a determinant in which the first row will represent I cap, J cap, K cap, and the second row will represent A1, A2, A3. The third row will represent 1, 0, 0. Now if we expand it along R3, because it contains maximum number of 0, so here 1 is coming at the first row, sorry, third row and first column. So 3 plus 1 is 4, which is even. So it will take the value of plus sign, and for it the corresponding determinant will be J cap, K cap, A2, A3. So it will give A vector into I cap as A3 J cap minus A2 K cap. Modulus of this will be under root A3 square plus A2 square, and then the square of this modulus will be A2 square plus A3 square. Now similarly, if we observe the pattern here, with I cap product it is given A2 square plus A3 square. That means except for I cap, it is giving the value for J cap and K cap. Okay, that means what I'm trying to say is, if A vector is written as A1 I cap plus A2 J cap plus A3 K cap, so with cross product with I, it is taking the square of product of J cap and K cap coefficient. That means with J cap it will take the I cap coefficient and K cap coefficient, and with K cap it will take the coefficient of I cap and J cap. So observing the given pattern, we can write the modulus square of A vector into J cap as A1 square plus A3 square, and modulus square of A vector into K cap as A1 square plus A2 square. Now if we add all these three things, we are getting twice of every square term, that is 2 times of A1 square plus A2 square plus A3 square, and this is equal to 2A square, and 2A square is corresponding to the option number B. Okay, so this question is, as far as I am concerned, is the not moderate type. It is little bit difficult type, but it can be easily solved if you know the basic concepts and logic. Now let's come back to the question number 17. Again, this question is asked from the chapter of vector, and this is also a very moderate type but yet very logical question. Now here two vectors are given with mod as 1 and 2 and dot product as root 3. We are asked to find the angle between 2a and minus b. So first of all, we will find the angle between a vector and b vector using their dot product formula, that is cos theta as a vector dot b vector divided by modulus of a and b. And cos theta is coming as root 3 by 2, and when cos theta is equal to root 3 by 2, theta will be 30 degree or pi by 6. So here theta 30 degree or pi by 6 is the angle between b vector and a vector, not minus b and 2a vector. So how to find the angle which is required here? So first make the twice of a vector, which is 2a, along the same line, and for minus b vector you have to reproduce b vector in the opposite direction. Now using the property of linear angles, this straight line will correspond to total of 180 degree. So this remaining angle on the left side will correspond to 180 minus 30 degree, which is 150 degree. Now convert 150 degree into radian, you will get answer as 5 pi by 6. Now 5 pi by 6 is corresponding to the option number C. Okay, Now comes to the last question of MCQ based, which is function fx equal to kx minus sin x is strictly increasing from what value of k. So this question is asked from the chapter of application of derivative. So here, for strictly increasing, we know that f dash x should be greater than 0. So first calculate the f dash x. We are getting f dash x as k minus cos x, because x differentiation is 1 and sin x differentiation is cos x. Now when we make this as f dash x greater than 0, we will get k greater than cos x. Now what is the range of cos x? The range of cos x is from minus 1 to 1. In this range, we will take the value of k corresponding to the maximum value of cos x. Maximum value of cos x is 1. So for increasing, it should be greater than 1. That means k should be greater than 1, and k greater than 1 is coming in the option number A. Okay. So option number A, corresponding to k greater than 1, is the correct answer for this question. Now let's go to question number 19. So from question number 19, we will get assertion region based question, and then 19 and 20 both are assertion region based question. And here question number 19 is again asked from the chapter of LPP, that is linear programming problem. So here a graph is given, and in this graph corner points are already uh, given P, Q, R, S, and for this corner point we are asked to find the maximum value, and the maximum value is to be calculated using z is equal to x plus 2y. Okay. Now in the assertion it is given that the corner points are PQRS, and the maximum value for this z will occur at infinite point. And the reason here it is given as the optimal solution of LPP having bounded feasible region must occur at corner point. Okay. So reason is true, no doubt, because optimal solution always occur at some of the, or at least one corner point of the bounded feasible region. But why this LPP has infinite solution? Let us try to find out. So corner point are PQRS. So if we tabulate that, P is corresponding to 60, 0. For 60, 0, Z value will come as 60. For Q it is coming 120, and for R also it is coming 120, and for S it is coming 80. For 2 points we are getting as maximum value 120, 120. And for such cases we can say, if the z value is x plus 2y, which is nothing but a equation of a straight line. So if for a straight line 2 points are having a maximum value, that means uh, the corner point will have the maximum value at 2 points. The corner points correspond to maximum value, and all the points on this line will also have the exact same value. That means there are infinite number of points at which z max will occur. So this is the correct reason due to which this z is giving maximum value at infinite number of points. Z is not giving maximum value because optimal solution occur at corner point. Although reason is true, assertion is also true, but reason is not the correct explanation of A. Therefore, option number B is correct answer for assertion region question number 19. Now let's go to the last question of this video, that is question number 20. Here assertion is given as the relation R is equal to set of all x comma y such that x plus y is a prime number and x comma y belongs to natural number. Is not a reflexive relation, and the reason is given that number 2n is composite for all natural numbers. So this question is asked from the chapter of relation and functions. So we have to remember that whenever relation R in a set A is reflexive, it is given for a condition that A comma A should belong to relation R for every A belonging to A. That means कि A comma A should belongs to relation R for every a belonging to natural number set. So if you try to write the values for r in the set of order pair, we will get 1 1 1 2 2 1, but we will not get the value 2 2 in this relation, because 2 plus 2 is 4 and 2 plus 2 is equal to 4, and 4 is not a prime number. So 2 comma 2 does not belong to this relation. That's make this relation as non-reflexive, because 2 comma 2 should also belong to this relation to make this relation reflexive. So that's why this relation is not reflexive. But here reason is given that 2n is composite for all natural number. So we have to check that also, that reason is true or not. So we can say 2 into 1 is 2. 2 is a prime number, but it is given that all 2n types number are composite numbers. So that means 2n is composite for all natural number except 1. So but 1 is a natural number. That means reason here is false and assertion is true. So option number C will be the correct answer for this question. So this for this question number 20, option number C will be the correct answer. So this complete the section A of this math question paper. Now in the next video I will try to solve section B, C, D and E. Okay, so I hope you have learned a lot of concepts and logic from this question from section A, and it contains 20 questions. In the next video we will see solution to section B, C, D and E. Okay, thank you for watching this video and have a nice day.